Good morning, children. In today's class, we are going to learn about some properties of definite integrals. Property number 1, integral a to b f of x dx can be rewritten as integral a to b f of u du. Whenever I say a to b, a should be below b. What is the difference between these two? Here I use x, here I use u. No other change. This tells us in every integrand throughout I can change the variable. That is, instead of x, I can put u, I can put t, I can put y depending on my need. Second property. A to B, when I interchange, A to B is becoming B to A. What is the extra fitting? Minus symbol. See, morning you come from home to school. Evening you go back from school to home. Home to school, school to home. Distance or the area covered doesn't change. But what changes? The direction. Morning you go forward, evening you come backward. So the direction changes, nothing else. So whenever direction changes, change the symbol. So A to B, I will write minus B to A. The third property, A to B, if I want, I can split like this way. Again, you start from home. You reach your friend's place and then you go to school. So, starting place is A, ending place is B. But if you want, you can reach on the way somebody's place, not beyond your way, on the way. So, A to B integral, how do I write it? A to C, C to B. How do I write it? A to C, C to B. That is the idea mentioned. Not one friend. You can have many. A to C, C to D, D to B. Like this also I can write. So, if I introduce upper limit, you introduce lower. It gets cancelled. Introduce upper and lower cancelled. Ultimately, I will have A starting, B ending. So, my starting and ending I do not change. In between, I can have stopping. A to C, C to D, D to B. Not 2. How much ever I want, I can introduce, provided the number that I take is in between A and B. So, C should belong to the interval AB. Fourth idea, when you have alpha into f of x plus beta into g of x in the integral A to B, I can split it. A to B, first one, A to B, second one. In that again, alpha is the coefficient, keep it out. Beta is the coefficient, keep it out. Whenever alpha and beta are constants, treat them as coefficient, keep it out the integral. So, alpha into integral A to B f of x dx plus beta into integral A to B g of x dx. Whenever you put integral, remember to put dx also. The next property, property number 5. Integral A to B f of x dx. Wherever x is coming, I can substitute lower limit plus upper limit minus x. A plus B minus x. This model is helpful mostly in trigonometric functions, where The lower and upper, if I add, it may lead to pi by 2. And I know pi by 2 minus x is coming. Sine will become cos and cos will become sine. So, these are the ideas which lead us to ease our calculation. So, wherever x is coming, you can very well substitute a plus b minus x. There is no change in dx or integral or the limits. The next property, if the limit is from 0 to 2a, I can write it as 0 to half of this. 2a tells me put a, half of this. When you keep the function as it is, the second part, upper limit minus x. So I write f of x plus f of 2a minus x. The most important property that we often use in objective type problems is when f of x is even. See, my limits are from minus a to plus a. In between definitely 0 will come. Minus a to 0 and 0 to a are same, but changes in symbol. If both are positive, I will write twice 0 to a. If one is plus and the other one is minus, they get cancelled, giving us 0. How am I to check whether both are plus or one is plus, one is minus, all that? If f of x is even, both will have same symbol, put twice. If f of x is odd, one will be plus, the other one will be minus, and I will get 0. How do you declare a function is even or odd? See, if I say f of x is x square tells me even if I put minus x, my answer is x square only. So whenever f of x is f of minus x, I will declare even function and the condition is here. Whenever it is even, twice 0 to a I can rewrite. Suppose x cube is coming. Minus x the whole cube will be minus x cube. Now f of x and f of minus x changing in symbol. In that case, I will call it as odd function. In general, you can remember x powers even, it is an even function. X powers odd, it is an odd function. In trigonometry, again, the power is even, sine square x, square is coming, it is even function. But sine x is coming, you should remember only cos x and secant x are even, because even tells me if I go in plus theta, I am in first quadrant. If I go as minus theta, I am in fourth quadrant where cos and secant are positive. So only these two are even. All the remaining ratios, say sine, cosecant, tan, cot, they are all odd functions. Even function is only cos and secant. Cos power anything even only. Secant power anything even only. But the other ratios, sine, tan, cot, if the power is even, it is even. If the power is odd, it is odd. Remember in that way. Suppose I give you a problem. An example, x square plus x cube. What function it is? Here even power, here odd power. This is even, this is odd. When I add even plus odd, my answer is neither even function nor odd function. Remember, It is not ordinary numbers, we are in functions. So in a function, if everything is even, my answer is even. If everything is odd, my answer is odd. But one is even, one is odd, then I will say neither even nor odd. So both the properties will not help in such models. Fully even, I can use this idea. If it is fully odd, I can use this idea. There are functions where partly even and partly odd. When I add both, I will declare such functions are neither even nor odd. I cannot use both the properties. The next idea, 0 to a. X f of x dx is coming. If I multiply with x, integration may be difficult. So I have an easy property to remember in most difficult problems. Whenever x into f of x is coming, check f of a minus x is f of x. If so, you can rewrite this answer as whatever limit is here by 2. A by 2 integral 0 to a f of x dx. Similarly, 0 to 2a f of x dx is coming. I can write it as 2 times integral 0 to a f of x dx provided f of 2a minus x is f of x. Remembering all the properties at a glance may be difficult. We will recall and relate to each problem that we are going to learn in the exercise. Exercise 9.3, question number 2, subsection 1, integral minus 5 to 5x cos e power x minus 1 by e power x plus 1 dx. As I see the problem, consider the function as f of x. The limits are from minus 5 to plus 5, negative number to positive number. I recall integral minus a to a f of x dx. Check the function is odd or even. Find out f of minus x. Wherever x is coming, put minus x. Minus x cos e power minus x minus 1 by e power minus x plus 1. That is minus x cos e power minus x is 1 by e power x minus 1 by e power minus x is 1 by e power x plus 1. Taking the LCM, 1 minus e power x by e power x divided by denominator e power x, again LCM, cross multiply 1 plus e power x. E power x cancels. I can write it as minus x cos 1 minus e power x by 1 plus e power x. Change the symbol, that is take minus symbol out. It is minus e power x minus 1 by e power x plus 1. Denominator I copy as it is. Numerator I have taken a minus symbol. You remember the formula, cos of minus theta is cos theta, because cos is an even function. So cos of minus e power x minus 1. I can ignore this minus symbol and write minus x cos e power x minus 1 by e power x plus 1. Compare this and the function. The symbol is minus. So I will write minus f of x. LHS I have f of minus x. Whenever the sign is changing, I will declare f of x is odd. And whenever it is odd, remember the formula. Integral minus a to a, f of x dx is 0 if f of x is odd. So this question, integral minus 5 to 5 x cos e power x minus 1 by e power x plus 1 dx equals to 0. Because I apply the formula f of x is odd, minus a to a, integral f of x dx is 0. So applying that, we arrive at 0 as this answer. Second subdivision, integral minus pi by 2 to pi by 2. X power 5 plus x cos x plus tan cube x plus 1 dx. Given a problem like this, as I check the powers, x power 5, it is odd. X power 1, it is odd. Tan power 3, that is also odd. So these three functions, as I check, they are odd. Let me split and write it, because if I come to know it is odd, I can immediately say my answer is 0. So minus pi by 2 to pi by 2, x power 5 plus x cos x plus tan cube x into dx plus integral minus pi by 2 to pi by 2 1 dx. This answer I will say f of minus x equal to minus f of x. So it is what function? Odd function. So using this formula, I can immediately say the answer is 0. Whereas here, I can just integrate. 1 will become x. Upper limit pi by 2, lower limit minus pi by 2. Put upper limit minus lower limit. It is pi by 2 plus pi by 2, which is 2 pi by 2, or I will simply say pi, and that is the answer. Question number 3. Integral minus pi by 4 to pi by 4 sine square x dx. Sine square x is an even function. Whenever it is an even function, from minus pi by 4 to pi by 4, I can rewrite as twice integral 0 to pi by 4, applying this formula sine square x dx. We know from trigonometry, sine square x can be rewritten as 1 minus cos 2x by 2 dx. 2, bring the 2 out. 2 and 2 will get cancelled. 1 constant will become into x minus cos 2x formula sin 2x by 2. As we integrate, 1 will become x, cos 2x, the formula is sin 2x by 2. This 2 we have taken out, which gets cancelled. The limits are from 0 to pi by 4. Wherever x is coming, put upper limit. Pi by 4 minus sin 2 into pi by 4 by 2. Then lower limit, x is 0, sin 0 is also 0. Simplifying this answer, I equals pi by 4 minus 2 cancels here, giving us sin 90. Sin pi by 2. Sin pi by 2 is 1. So I get 1 by 2. Leave the answer like this, or taking LCM. It is pi minus 2 by 4, and that's the final answer. Fourth subdivision, I equals integral 0 to 2 pi x log 3 plus cos x by 3 minus cos x into dx. X into something, whenever it comes, directly doing the integration may be a difficult process. Remember the formula. when the limits are starting from 0 to some number. Call it as integral 0 to a x f of x dx. I can rewrite a by 2. Simply integral 0 to a f of x dx, provided f of a minus x equal to f of x. Consider this term as f of x, whatever is other than x. Find out f of 2 pi minus x. Log, wherever x is coming, put 2 pi minus x. Remember the formula. Cos 2 pi minus x is cos x only. In fourth quadrant, this is 0, pi by 2, pi, 3 pi by 2, 2 pi. And this is 2 pi minus x, that is fourth quadrant. I get cos x as it is. Denominator, the same idea, it is again cos x only. So, f of x and f of 2 pi minus x are equal. Check this condition, it is done. So, I can use the formula I equals. Instead of x, I will write a by 2. 2 pi by 2 integral 0 to 2 pi. F of x, that is log 3 plus cos x by 3 minus cos x dx. As we cancel 2 and 2, 0 to 2 pi can still be remembered with another property of definite integral. As I apply this property, pi comes as it is. 0 to 2 pi, this integral becomes twice 0 to pi. 2a becomes a, 2 pi becomes pi. Log dx, no change, write as it is. Because we have shown here 2 pi minus x, if I put, I get the same f of x only. Now call this as number 1. The next step. Use the property integral 0 to a f of x dx equals integral 0 to a f of a minus x dx. So I equals 2 pi integral 0 to pi. Wherever x is coming, let us put pi minus x. Log 3 plus cos pi minus x. So pi minus x will come here, which is second quadrant, where cos is negative. So plus cos pi minus x will become minus cos x. Denominator, the same idea. Cos pi minus x is minus cos x. There is already minus symbol, gives us plus cos x. Call this as number 2. We shall add 1 and 2. I plus I equals 2 pi common in both. Integral 0 to pi common in both. Here I have log 3 plus cos x by 3 minus cos x plus log 3 minus cos x by 3 plus cos x into dx. In logarithm, I know addition represents multiplication. So LHS 2i, RHS 2 pi, integral 0 to pi, log 3 plus cos x by 3 minus cos x into 3 minus cos x by 3 plus cos x into dx. The terms get cancelled, giving us only log 1. And log 1 is 0. When log 1 is 0, integral of 0 is again 0. So I get 2i is 2 pi into integral 0 to pi 0 dx, which is 0. 2i is 0 tells me I is also 0, and that is the answer.